Next, we'll look at the temperature and pressure dependence on solubility of gases in water. Gases generally have lower solubility in water than ionic or polar covalent solids because they are nonpolar molecules in general. Gases that have high solubility are usually reacting with water, or they're polar gases. For example, ammonia. For all gases, the solubility of the gas decreases as the temperature increases, and the delta H of solution is exothermic because you don't need to overcome the solute attractions. Here we see someone pouring soda pop into 2 glasses. There's cold soda pop on the left and warm soda pop on the right. So we see that the warm soda pop has more bubbles than the cold one because it's releasing more of the gas. And this is because cold gases are more stable. So gases are more stable in a cold solution. A solution is saturated with both nitrogen gas and potassium bromide at 75 degrees C. When the solution is cooled to room temperature, what is most likely to happen? A. Some nitrogen gas bubbles out of solution. B. Some potassium bromide precipitates out of solution. C. Some nitrogen gas bubbles out of solution and potassium bromide precipitates out of solution. Or D. Nothing happens. Some potassium bromide precipitates out of solution because at colder temperatures, the nitrogen gas would be more stable. Increasing the pressure of a gaseous solution increases the solubility of a gas in a liquid. The larger the partial pressure of a gas in contact with a liquid, the more soluble the gas is in the liquid. So here we see 2 cans of soda pop. On the left, the can is unopened, and we see that when the CO2 is under pressure, the CO2 remains dissolved in solution. But when the pressure is released by opening the can on the right, the CO2 bubbles out of solution. We can determine the solubility of a gas in water according to Henry's law. Henry's law states that the solubility of the gas is equal to K sub H, the Henry's law constant, times the partial pressure of the gas. Here we see Henry's law constant for several gases. Examine the Henry's law constants in table 14.4. Why is the constant for ammonia larger than the others? We see here that ammonia is 5.8 times 10 to the first, so like 58. O2 is in the 1.3 times 10 to the negative third, and we see that the others are 10 to the negative something, right, on the order of 10 to the negative something. So ammonia is much larger. And this is because ammonia is polar, and the other substances, being gases, are nonpolar, because most gases are nonpolar. But additionally, the ammonia is reacting with the water, and that's another reason why it has a large Henry's law constant.